Good morning. I'm Lakshmi, Associate Professor, Electrical and Electronics Engineering Department, VJIT. I would like to discuss on control systems, types of control systems, and types of controllers. So before going to learn about all these types of control systems, that means the classification of control systems and the different kinds of controllers, what are the prerequisites of this course? The prerequisites of this course are linear algebra and calculus, ordinary differential equations and Laplace transforms, numerical methods, and complex variables. What are the course objectives of this course? To understand the different ways of a system, representations such as transfer function representation and state space representations, and to assess the system dynamic response, to assess the system performance using time domain analysis and methods for improving it, to assess the system performance using frequency domain analysis and techniques for improving the performance, to design various controllers and compensators to improve system performance. These are different course objectives of this course. Now let us understand what is control system. A control system is defined as a system of devices that manages, commands, directs, or regulates the behavior of other devices or systems to achieve a desired result. A control system achieves this through control loops, which are a process designed to maintain a process variable at desired set points. So to understand about control system, first of all, how this control system is related to our electrical engineering, let us try to understand. First of all, control system is not confined to electrical engineering. It is a diversified course. So it is diversified to all the core engineering subjects. That means, let us talk about, the day-to-day life. So let us take a human body. Okay, our human body itself is a control system. How can we say that our human body itself is a control system? Our brain, our brain is activating all our actions. So the brain is controlling all our actions. Okay, so we can say that our human body itself is a control system. Our brain is controlling all our actions. So we can say that brain is one of the controller. Okay, so now let us talk about our control system, which is used in our electrical engineering. A control system is defined as a system of devices. It is a system of devices that manages, that commands, that directs, regulates the behavior of other devices or the systems to achieve a desired result. I want a desired result. So in order to achieve the desired results, how, the plant means whatever the system which we are taking, okay, is being managed, is being commanded, is being directed to regulate the behavior of other devices or systems to achieve the desired output is known as a control system. Generally, a control system achieves all these through the control loops. Loops means it's in the form of feedback, which are a process designed to maintain a process variable at a desired set point. So what do you mean by a plant here? So I told you that, control system is regulating the system, which is also known as a plant. The portion of a system which is to be controlled or regulated is called as a plant. So we need to control the we need to control the plant or a system. So the portion of that particular system which is to be controlled or to be regulated is called as the plant. A plant may be a piece of equipment or just a set of machine parts. What do you mean by a plant? Plant is an equipment, or it is also a set of machine parts. The purpose of a plant is to perform a particular operation. So what is the purpose of a plant? The purpose of a plant is to perform a particular operation. For example, mechanical device, a heating furnace, a chemical reactor, or a spacecraft. All these are, we can say that these are the examples of the plants. So next comes the process. Any operation to be controlled is called as a process. We can call a plant also called as a process, or a plant, we can call it as a plant or a process which is to be controlled, which is being controlled, okay, with some operation. Any operation to be controlled is called as a process. Examples are chemical, economic, and biological processes. Next one is a controller. So in order to control the plant, we should have some controller, isn't it? As I said before, how brain is acting as a controller to, activate all our actions. So we can call that brain to be the controller. So similarly here also, in order to control the plant, a controller is required. So the element of the system itself or external to the system which controls the plant or the process is called as a controller. So the system itself, the elements of the system itself, or external to it, okay, which controls the plant or the process is called as a, we can call it as a controller. So example is an on-off switch to control the bulb. A general simple example is an on-off switch, which is controlling a bulb, switching on and off of a bulb. So we can call it as a switch as a controller over here. Okay, next one. Next is input and output. So what do you mean by input here? See, any system without giving input, we can't expect the output. So, and here in this control system, along with the controller, along with the plant, along with the process which is happening, we should have an input such that an output is obtained, right? So what is the input here? It is an applied signal or an excitation signal applied to control system from an external energy source. So it is an applied signal or an excitation signal which is applied to control system from an external source or an external energy source in order to produce a specified output. I want a desired output. So in order to obtain the desired output, okay, first of all, I should give the input signal, right? So it is an applied signal which is applied external to the external energy source. It is from an external energy source, it is applied to the system. So for each system, there must be excitation and system accepts it as an input. So every system must have an excitation and the system accepts it as an input. Okay, so we can call this as an input. Next comes output. So it is a particular signal of interest or the actual response obtained from the control system when input is applied to it. Just now I told you that, any system without an input, we can't expect an output. Okay, once the input is given, okay, in order to obtain the desired output, right? So it is what do you mean by output over here? It is a particular signal of interest or the actual response obtained from a control system when input is applied to it. So for analyzing the behavior of the system for such inputs, it is necessary to define the output of a system. First of all, we should fix the output, like what is the output we are expecting. Okay, so in such direction, whatever the output which we are expecting, that is called a desired output which we are expecting, in such a way that the input is manipulated in order to obtain the desired output. Okay, so if you just observe this, this block diagram, we call this as a block diagram. If you just observe this block diagram, wherein there is a command input which is given to the controller, wherein the purpose of the controller, what is the purpose of the controller is, it will be manipulating the signal. Okay, and a manipulated variable is generated, which is the output of the controller, which is given to the process. Okay, so there will be disturbances also in the system. The disturbances may be internal disturbances or the disturbances may be external disturbances also. So the process not only is affected, or we can say once we give the input signal, uh, the disturbance input is also taken as an input to the process. So the main cause for not obtaining the desired response is these disturbance signals only. Okay, so we should search for a means in such a way that to obtain the desired output, even though there is a disturbance signal, we should obtain the desired output. So these signals cannot be avoided because they are external, they may be internal, these disturbances cannot be avoided, right? So the main motto here is here for the control system is in order to obtain the desired output. So what is the desired output is first of all, that is first fixed, and then according to that we'll be acting, okay, manipulating the input variables in order to obtain the desired output of the system. Next comes, just now I told you, disturbances. So disturbance is a signal which tends to adversely affect the value of the output of the system. Okay, so due to these disturbances only, we could not obtain the desired output. There are means to, even though you have a disturbance in the system, there are means to obtain the desired output of the system. So first of all, we should understand what is disturbance. Disturbance is a signal which tends to adversely affect the value of the output of the system. The disturbances are undesirable. They are, you cannot expect those disturbances, but they will be coming into picture, and unavoidable. Okay, you can't avoid those because they may be external due to the environmental changes or due to the internal. Okay, so you cannot avoid such disturbances. So disturbances are undesirable, and disturbances are unavoidable effects beyond our control, generated from outside process or the process environment, and from within it. So if such a disturbance is generated within the system itself, it is called as an internal disturbance. So for example, if that particular disturbance is generated within the system, we call it as a internal disturbance. The disturbance generated outside the system, acting as an extra input to the system in addition to its normal input, affecting the output adversely, is called as an external disturbance. So whether it may be an internal disturbance or it may be an external disturbance, these disturbances are going to adversely affect the output of the system, right? The presence of the disturbance is one of the main reason of using the control. So why control is necessary? Why control is necessary? Because of these disturbances only. See, if there are no disturbances in the system, just you give the input and you could obtain the desired output. There is no problem. Okay, so there is no controlling action happening here. But whenever there are disturbances in the system which are unavoidable, then only there is a need for control is coming into picture, right? So if you just observe, I just told you that a controller is there, you are giving some command input, it is being manipulated in order to obtain the desired output. So disturbance input is coming as an extra input to the system, which is adversely affecting the output of the system. So there should be some means, okay, in order to obtain the desired output, even though disturbances are there in the system. So due to these disturbances which are occurring in the system, the control action has to be activated. So controlling has coming into picture. Okay, next. So just now I told you that what do you mean by a control system, right? So it is consisting wholly of just now we discussed about, there is an input, right? Input is given to a controller, there is a controller is manipulating the signal, then it is giving it to the plant. Okay, so then a desired output is obtained from the system, right? So this is all the process which is happening, right? So we have different classification of control systems. So control systems are mainly two categories. First thing is natural control system, and another one is man-made control system. In return, man-made control systems are again subdivided as manual and automatic. Okay, nowadays we have all automatic control systems. Okay, we are not seeing this manual kind of control systems. So all are automatic control system are there. Now, in again automatic control systems, there are open loop systems, there are closed loop systems. Then again, from open loop systems, there are non-linear control systems and linear control systems. So now coming to closed loop control systems, there are again subdivisions which are non-linear control system and linear control system. In that non-linear, again you have time variant and time invariant. Next, coming to linear, there are time variant and time invariant kinds of control systems are there. These are different classifications of control systems. Now coming to in detail into the classification of the control system. First one is natural control system, universe. So the best example for natural control system is the complete universe. Next comes the human body. Our human body itself is a control system. So let me elaborate on this example of how a human body is the example of a control system. Let us suppose I am getting so many bad thoughts. Let us suppose. Okay, so I just want to control my thoughts. Otherwise, I may commit a mistake, or I may commit a sin kind of thing. So how to choose from the best or from good and bad? Who is going to judge you? Who is going to tell you that this is good and this is bad? So always, our heart says that what is good and what is bad, but our brain says, our brain always tries to drag us towards the bad. Our heart says what is good and what is bad. It directly clarifies that what is good and what is bad, right? So heart says that this is good and this is bad, right? This is giving signal to the brain. Then brain, what it does, it will be controlling our actions, whether to go for the good or to go for the bad. So in this way, we can say that a human body is completely acting as a control system. Okay, either the heart or the brain is controlling our actions, right? So next one is a man-made control system. Vehicles, aeroplanes, all these are the best examples of man-made control system. Next comes the manual control systems. Room temperature regulation through electric fan. Okay. Next, water level control. This is a manual control system. Next one is automatic control system. Room temperature regulation through air conditioning system. Human body temperature control. These are all automatic control systems, right? Next comes open loop control system and closed loop control system, which we are going to discuss about open loop and closed loop in detail. Now, if you just observe the figure over here, there is a control system wherein you have given some input and you are obtaining some output over here. So here, if you just observe, there is no closed path or a closed loop. Just you are giving input and you are obtaining the output over here. Such systems are called as open loop control systems. The best example is a washing machine, a toaster, and an electric fan. These are all the open loop control systems. Next, coming to closed loop control systems. If you just observe, what is the difference between the open loop control system and closed loop control system over here? There is a feedback present for a closed loop control system. So the best example is a refrigerator, an autopilot system, a driverless car. These are all the closed loop control systems. So how can I say that? Let me elaborate. The example of a closed loop control system. I have a driverless car. So Driverless car is one of the good example of a closed loop control system. Next comes linear versus non-linear control system. A control system in which output varies linearly with the input is called a linear control system. Output varies linearly with input is called as a linear control system, right? Next, time invariant versus time variant control systems. When the characteristics of the system do not depend upon time itself, then the system is said to be time invariant control system. Time varying control system is a system in which one or more parameters vary with time. Okay, such type of control systems are called as time varying control systems. Next comes continuous data versus discrete data systems. In continuous data control system, all system variables are functions of a continuous time. In discrete control system involves one or more variables that are known only as discrete time, that are known only at a discrete time intervals. Deterministic versus stochastic control system. A control system is deterministic if the response to the input is predictable and is repeatable. So we say that if you already know the output and we are targeting over that particular output, okay, with that which we call it as a predictable or repeatable. So we say that that particular control system is a deterministic control system. Next comes stochastic control system. If it is not predictable, it is not repeating, then we call it as a stochastic control system. Now let me elaborate more on this open loop control system. Okay, what do you mean by an open loop control system? If you just observe, this block diagram, if you just observe that, okay, which is consisting of block kind of things along with, the process flow, which is shown with the arrows. So such a diagram is called as a block diagram. So there is a controller and there is a process, right? So your desired process response is given, whatever the response you want, that is given. Next, controller output process input is taken from the controller output, which is given to the process, and then you are going to obtain the process output. This is what is shown in the block diagram, which is represented here. So any physical system which does not automatically correct for the variation in its output is called as an open loop control system. Okay, so it will not automatically control for any kind of variations. Okay, any kind of variations, if it is not automatically correcting, such control systems are called as open loop control systems. Okay, that is represented by the block diagram over here. So in these systems, output is dependent on input, but controlling action or input is totally independent of the output or changes in output of the system. Next comes, in these systems, the output remains always constant for a constant input signal, provided the external conditions remain unaltered. Okay, all these, in these systems, the output remains a constant for a constant input signal, provided the external conditions remain unaltered. See, the main point over here is in case of open loop control systems, okay, these are going to give you the accurate results for no disturbances in the system. If there are disturbances in the system, you cannot have the controlling action for this open loop control system. So open loop control systems gives you the best results if there are no disturbances in the system. So that is the meaning of this point. In these systems, the output remains constant provided the input is constant and all the external conditions are unaltered. Okay. Next, in any open loop control system, the output is not compared with the reference input. It is not going to compare because there is no such comparator over here in this in the block diagram which we have shown. So in return, when it is not comparing, the output to the input, Okay, where the accuracy point comes here. So open loop control systems are deficit in the accuracy point of view. So as a result, the accuracy of the system depends on the calibration. Okay, so in the presence of disturbances, if you have disturbances in a system, an open loop system will not perform the desired task. This just now I told you that. So whenever the open loop systems are going to give you the best results only when the disturbances are unaltered in the system. So for example, if there are disturbances, then open loop systems will not perform the desired task. So open loop control can be used in practice only if the relationship between the input and the output is known, and if there are neither internal nor external disturbances in the system, then only these are going to give you the best results. For instance, let us suppose a traffic control by means of signals operated on time basis is an example of a control system. So now and then we are going on roads and we are observing the traffic signals on the road, right? Isn't it? So, the signals which are red, yellow, green lights which are there at the signal point. Okay, there is a preset time for them. Okay, so let's suppose 50 seconds, one light has to glow, 50 seconds another light has to go, and 50 seconds another light has to go, let us suppose. So this preset time is already set. Okay, and they are activated depending upon the time which is given to them. Okay, then that becomes an open loop control system. They are not taking, it is not taking into account the density of the traffic, which the traffic flow on the road is not taking into account the traffic flow on the road, the density of the traffic. Okay, so just whatever the preset time which is set to it for all the colors of lights, if it is acting, so we call it as an open loop control system. So that is the reason why the traffic control by means of signals operated on time basis is an example of open loop control system. So now comes, what are the advantages of open loop control system? I told you that there is no controlling, the input. You are giving some input and you are obtaining some output, right? So here you are giving input and you are obtaining output. It is only giving results for the systems which are for the systems in which the external conditions are unaltered. So the advantages of open loop control systems are such: these systems are not involving any closed loops or closed paths, whatever, whatnot. So these are very simple in construction. Okay. Next, very much convenient when the output is difficult to measure, right? Next, generally, these are not troubled with the problems of stability. These are not troubled with the problems of stability, because stability is one of the main point which has to be focused, right? So open loop control systems are best in stability, right? These are not troubled with the stability point of view. Such systems are very simple to design and hence economical. Very simple to design because there are no control loops which are present in the system. So this is very simple to design, and it is also economical. There is no control loop. There are no feedback devices. Nothing is there. So we can say that it is more economical also. So it is very simple in construction. Next, very convenient. Next, they are not troubled much with the stability point of view, and it is very simple to design, and also it is economical. Now comes what are the disadvantages of this system. These systems are inaccurate and unreliable because accuracy of such systems are totally dependent on accurate pre-calibration of the controller. So the point over here is there are no controller, there are no feedback elements here. So output is not compared with the input. If output is not compared with the input, how can you know how accurate my system is working, right? So That is the reason why we call it as inaccurate and unreliable, because accuracy of systems are totally dependent on the accurate pre-calibration of the controller. So these systems give inaccurate results if there are variations in the external environment. See, I told you already that open loop systems are going to give you the best results when the external conditions are unaltered. So these systems give inaccurate results if there are variations in external environment. Next thing is, these systems can't sense internal disturbances in the system after the controller stage. So in the block diagram, we have seen that there is a controller, then controller is giving its output to the plant, then plant is going to act. All these things we have seen, isn't it? So after the controller stage, if at all any disturbance occurred internal in the internal circuit or internal, kind of a system, then it is not going to sense, right? So these systems, that means open loop systems, can't sense internal disturbances in the systems after the controller stage. Next one is, recalibration of the controller is necessary time to time to maintain the quality and accuracy of the desired output. Okay, always the controller has to be recalibrated for accuracy, whether I am getting an accurate result or not. So for this, that controller has to be now and then recalibrated on the time basis, and then it has to be such that you can have a quality and accuracy of the desired output. Now coming to the examples of open loop systems. An automatic toaster system is one of the example of open loop system. So if you just observe the block diagram over here, there is a heating process. Now I am going to heat the bread in my toaster, which I have in the which is called an automatic toaster system. So there is a relay or the controller, we can call it. It is called the controller here. We are setting some desired time. You are giving the power input. Okay, we are giving the power input over here. Then it is again given to the heating process of the bread, which is called the process or the plant over here, and you are going to check the desired output in the form of how best the bread is toasted, right? So in this system, the quality of toast, right, the quality of that particular toast depends upon the time for which the toast is heated. Next, depending on the time setting, bread is simply heated in the system, right? Bread is simply heated in the system. The toast quality is to be judged by the user and has no effect on the input. The quality of the toast has to be judged by the user itself. It has no effect on the inputs. Whatever the input is given, it is not having any effects. Next one is traffic light controller. Just now I told you that how the traffic light control action is happening. There are relays, okay, to control sequence. You are setting some desired time. Okay, power is input is given. A traffic flow control system used on roads is time independent. The traffic on the road becomes mobile or stationary depending on the duration and sequence of lamps glow. How the time is set in such a way that the duration and the sequence, how the duration is set, and then how in sequence the lights are blown. Okay, depending upon that, right, the traffic may be mobile or traffic may be stationary. The sequence and duration are controlled by relays which are predetermined or not dependent on the rush on the road, right? Next, they are not taking into account the density of the traffic, right? So we can call it as an open loop control system. Next one is residential heating system. The indoor temperature is the response variable of the interest that is affected by the main disturbance input, the outdoor temperature. The desired temperature is set on the calibrated dial. This positions the valve that admits the steam for circulation through the radiator. The valve dial is calibrated when the environment temperature has certain value. When this value changes significantly, the controller temperature will deviate from the desired value by a very large error, and hence precise control will not be realized. If you just observe the block diagram over here, so there is a temperature set point over here which is given to the valve. Okay, this valve is going to decide how much steam has to be admitted from it in order to heat the room, right? There is a radiator over here, right? There is some outdoor temperature which is also called as which is also taken as a disturbance input, and indoor temperature or the controlled input. So until unless this flow is continuing, there is the indoor temperature output is reached. So when the outdoor temperature you know is coming into picture as an error signal, then this indoor temperature is going to get reduced. So we cannot know how much it is, how much the room is getting heated. So there is no comparison of the indoor temperature with respect to the set point. So we can call it as the one of the example of the open loop control system. Right. Next one is closed loop control system. So these are also called as closed loop is also called as feedback control system, a system that maintains a prescribed relationship between the output and the reference input. How it is going to maintain by comparing them and using the difference as a means of control is called as a feedback control system. Feedback control systems are often referred to as closed loop control systems also. So in practice, the terms feedback control and closed loop control are used interchangeable, right? So in a closed loop control system, the actuating error, which is the difference between the input and the feedback signal, is fed to the controller so as to reduce the error and bring the output of the system to a desired value. The term closed loop control always implies the use of feedback control action in order to reduce the system error. If you just observe here a closed loop control system in the form of a block diagram, okay, so there is an error detector over here which is going to compare the output which is obtained with the input. So there is a command input here, there is a reference transducers over here, there is a reference input which is represented by the arrow. R of t is called as the input signal and E of t is called as an error signal, right? So the output which is coming, the output which is fed back from the feedback elements to the error detector is going to be compared with the input, and the difference is generated as an error which is given to the controller. So the controller is going to manipulate the signal in order to obtain the desired output of the system. The part of the output which is to be decided by feedback element is fed back to the reference input. The signal which is output of feedback element is called as feedback signal, B of t. So it is then compared with the reference input giving an error or error signal E of t is equal to R of t plus or minus B of t. When feedback sign is positive, the system is called as positive feedback, and feedback sign is negative, the system is called as a negative feedback system. The error signal which is generated is then modified by the controller and decides the proportional manipulated signal for the process to be controlled. This manipulation is such that the error will approach to zero. The signal then actuates the actual system and produces an output. As output is controlled one, hence we call it as a controlled output C of t. Now coming to the advantages of closed loop control systems. Closed loop control systems are best in accuracy, right? Because we are going to compare the output with the input, which is being done by the error detector. It is going to generate the error signal that is going to be manipulated and given back to the plant such that a desired output is obtained. Closed loop system senses environmental changes as well as internal disturbances and accordingly modifies the error. There is reduced effect on non-linearities and distortions in case of closed-loop control systems. The bandwidth, that means the operating frequency range for such a system, is very high. Now coming to the disadvantages of control system. Systems are complicated and time-consuming from design point of view, and hence also are costlier. Due to feedback, system tries to correct the error from time to time. Tendency to overcorrect the error may also cause an oscillations without bound in the system. So systems has to be designed taking into consideration the problems of instability due to the feedback. The stability problems are severe and must be taken care of while designing the system. Now coming to the examples of an closed loop control system, human being is an example of a closed loop control system. The best example is human being. If a person wants to reach a book on the table, position of the book is given as a reference. Feedback signal from eyes compares the actual position of the hand with reference position. Error signals is given to the brain. Brain manipulates this error and gives signal to the hands. This process continues till the position of the hands get achieved appropriately. Next comes a home heating system. So in these systems, the heating system is operated by a valve. Heating system is operated by a valve. The actual temperature is sensed by a thermal sensor and compared with the desired temperature. The difference between the two actuates the valve mechanism to change the temperature as per the requirement. So this is the block diagram which is depicting the home heating system, wherein a desired temperature is given to the error detector. Okay, the input which is here, along with the output, along with the value which is coming as an output from the feedback elements, then an error is generated and given to this valve. Then valve is going to give the heating system such that this is one of the example of home heating system. Next, coming to manual speed control system. A locomotive operated driver driving a train is a good example of manual speed control system. A person who is driving a car, okay, is also an automatic control system. The objective is to maintain the speed equal to the speed limit set. The entire system is shown in the block diagram as shown in the figure. So coming to the types of closed loop control systems, there are two kinds here, positive, depending upon the signs which we have in that error detector. One is positive feedback and one is negative feedback. So the output signal is sampled and then fed back the input to form an error signal that drives the system.